2024. We'll be covering about the eclipse, the eclipse that is happening tomorrow, April 8th, 2024. Also, we're going to be watching a video covering about the eclipse. I'm a little nervous today, but it's my first podcast, but it is 88 Real Talk Podcast. And I'm just liking you guys to be here, enjoy the video. Hit the like button, subscribe. Thank you, and enjoy it.
A total solar eclipse. It's a rare and astonishing natural phenomenon.
Seeing a total solar eclipse is like, whoa, you just never forget.
Solar eclipses have filled people with wonder. Roughly 400 times closer to the Earth, so it appears the same size in the sky as the sun. When it passes in front of the sun, it blocks the sun's light, casting a shadow on the Earth that plunges everywhere it passes into darkness.
That experience is surreal. It is not like any other experience that a human being can have.
At 11:07 a.m. local time on Monday, April 8th, the darkest part of the moon's shadow hits Mexico's Pacific coast. Traveling at more than 1,500 miles an hour, the shadow is over 100 miles wide, passing over Dallas at 1:40 p.m., through Arkansas and Illinois, over Indianapolis at 3:06 p.m., and Buffalo at 3:18 p.m. local time. This shadow will exit continental North America at 4:38 p.m. after touching 15 U.S. states.
It's a completely extraordinary coincidence that we get the angles just right to make this work. If we were anywhere else in the solar system, we would not have this perfect alignment.
And if the moon were any closer to Earth, or any larger, it would completely obscure the object the scientists are trying to study: the sun's outer atmosphere. It's called the corona. During a total eclipse, the corona comes into view as the moon passes in front of the sun.
So the moon has just made contact and started covering the sun's disk, and we call that first contact. And then the disk of the moon slides down and covers the disk of the sun, and we call that second contact. This is the magic moment. This is what we're all waiting for during a total solar eclipse. This is totality. The entire disk of the sun is covered, and that allows the sun's atmosphere that we call the corona to emerge and be visible. It just pops out, and you're just like, oh, wow.
But scientists on the ground only get a chance to study the corona if they're in the right spot and if the weather cooperates.
The bane of every eclipse chaser is clouds and other weather that keep them from seeing totality.
Statistically, Mexico should have the clearest skies along the path of totality during April, with Texas a runner-up. But most places north of Missouri have less than 50% chance of clear skies. Standing on the center line of the moon's shadow gives you the most time to view the corona. The last total solar eclipse to pass across the US was in 2017. It was an unforgettable spectacle, witnessed by an estimated 215 million people. But the maximum duration of totality was just 2 minutes and 42 seconds. In 2024, the maximum duration is almost twice as long, lasting 4 minutes and 28 seconds.
During the eclipse, that gives you a really unique opportunity to suddenly see this corona and to study it scientifically. The corona is less bright, quite a lot less bright than the main part of the sun. So normally, when you observe the sun, you're not able to see that corona.
The sun is so bright that until the moon completely covers it, the only way to view it safely is to use certified solar filters or eclipse viewing glasses.
It's really exciting to watch. But there is this real danger of blinding yourself or causing significant eye damage.
You've got to get these special eclipse glasses, these special eyewear that block out 99.999% of the sunlight and virtually all of the UV light that would really damage your eyes.
The human eye has a lens. It helps focus light onto the retina, which contains over 100 million light-sensitive receptor cells. These cells translate light into electrical signals that the brain can read as images. Staring directly at the sun, the focused beam from the lens becomes so intense, it can easily burn the cells in the retina, leaving a permanent blind spot. Eclipse glasses will prevent this, but the magnifying effect of telescopes and binoculars can still destroy your eye.
So you see what that light did to these viewing glasses? It would do the same thing to your eye. You'd blind yourself instantly. Even if you're wearing certified solar viewing glasses, you cannot look through a telescope with them unless there is a telescopic solar filter on the telescope itself.
During totality, that total darkness, you can actually take off your solar glasses and stare at the sun for just a brief moment and appreciate that darkness with that coronal light around it, which is one of these amazing moments that you can only experience if you're actually witnessing total solar eclipse.
But on April 8th, what about the people who are not lucky enough to live within or travel to the path of totality? What can they see? The good news is that nearly everyone in the US lower 48 has a chance to experience at least a partial eclipse. You see roughly 10% more of the sun with every 200 miles of distance from the path of totality. For example, in Atlanta, Georgia, the moon covers just over 80% of the sun's disk. In Los Angeles, California, around 50%. While in Portland, Oregon, just over 20% of the sun is blocked.
Imagine looking up at the sky with proper eye protection and noticing that part of the sun has gone missing. That is the joy and wonder of a partial solar eclipse. So even if you don't experience total darkness, you are still experiencing this wondrous phenomenon.
But only the darkness of a total eclipse allows us to see the sun's outer atmosphere, the corona. The corona's elusive pearly white cloud is made from a state of matter rarely found on Earth. plasma.
Sometimes we call plasma the fourth state of matter. There are many different states of matter, but the ones we're accustomed to here on Earth are four: solids, liquids, gases, and plasmas.
If you heat a gas to a high enough temperature, some of the electrons in its atoms fly off, leaving positively charged ions. This super hot mixture of ions and electrons is known as a plasma.
We don't see plasmas very often on Earth. Very briefly, as part of a lightning bolt, there'll be a plasma. But the sun, especially its corona, is this incredible plasma.
Although rare on Earth, plasma is a common state of matter in the visible universe. The stars we see in the sky are made from it, including our sun. With 1.3 million times more volume than Earth, our sun is a dense ball of plasma made from hydrogen, helium, and smaller amounts of other elements. The heat that creates this plasma is generated in the sun's core. Here, the extreme heat and pressure force the hydrogen nuclei to fuse together, creating helium and releasing vast amounts of energy as photons. This nuclear fusion heats the core to 27 million degrees Fahrenheit. From here, the photons pass through the dense inner layer of the sun. The temperature of the plasma gradually drops as the photons reach the sun's visible surface, known as the photosphere. Here, rising and sinking plasma forms a seething surface of light and dark areas. Around the photosphere is the corona, the sun's outer atmosphere of extremely diffuse plasma extending far into space.
The corona is called the corona because it sort of has this crown-like shape, and corona in Latin is the word for crown. It's thin and wispy and hence very dim compared to the actual surface of the sun. So we need that surface to be blocked in order to see the corona.
But what more could science discover if we could get closer? In 2018, NASA launches a pioneering space probe to do exactly that. It's called the Parker Solar Probe. On board are instruments that will change our understanding of the sun and study its extreme behavior.
Parker Solar Probe was conceived in 1958. There was a big long wait because our technology was trying to catch up with our dreams.
Go Delta. Go PSP. Look good in the full thrust mode.
Solar flares are large magnetic eruptions, which can cause particles streaming towards the Earth. We also have coronal mass ejections, which are billions of tons of material, equivalent to 80 million school buses racing towards us at millions of miles an hour, that can do things like interfere with satellites or affect our power grid.
But even when the sun is quiet, a lower intensity, steady outflow of charged solar particles forms what's called solar wind.
It has been a mystery as to why that wind is accelerating constantly off the solar surface. Parker Solar Probe is named for Eugene Parker, a very dear man who had a about the origin.
Sorry about that. I'm having some technical difficulties over here. Like I said, it's my first time podcasting, and I mean, I don't mean to interrupt in between, but still, I just wanted to make sure to touch base with you guys and let you know that I'm still here, and I'm really working on that technical difficulties. Just bear with me. Hit the like button when you come in. Please subscribe. Thank you.
Of the solar wind. That paper laid the groundwork for the study of the solar wind that we know today. Parker is the fastest human-made object. It'll reach speeds of 430,000 miles per hour.
A 4.5-inch thick heat shield.
Stand by, still working on it. Sorry about that. Just got to figure out what's going on here. Appreciate you guys patient with me. God bless. Thank you.
$270 in closing. Crew Dragon expected to converge with waypoint 1 directly in front of the International Space Station in less than 5 minutes. You can see the views right over the shoulders of Commander Shane Kimbrough and pilot Megan MacArthur. Kimbrough on the left, MacArthur on the right from that view.
But I do have something here with NASA.
From this view from the International Space Station, you can see what we were mentioning earlier, where Dragon was below the station. You could see that previously when it had Earth in the background. Now it is almost adjacent, or almost in the same orbit as the International Space Station, as it's making its way to the docking axis at waypoint 1. Maneuver from below the station to in front of the docking port is almost complete, just a few minutes away.
Getting great views from all around, from the station side, from the Dragon side. The outline of the station you see on the displays inside Crew Dragon is in line with the position of where Dragon is relative to the International Space Station. It's almost at the docking axis, about 2.5 minutes to go until it converges with waypoint 1.
And as a reminder, Dragon is flying autonomously, so they aren't using those display panels to fly Dragon. They're just using them to monitor each step of the way. Crew is basically just patiently waiting until they dock.
Thank you guys for being patient. I'm live right now. But when you do come into the live, hit the like button. Subscribe.
Draper laid the groundwork for the study of the solar wind that we know today. Is the fastest human-made object. It'll reach speeds of 430,000 miles per hour.
A 4.5-inch thick heat shield made from a carbon composite, painted with heat-reflecting ceramic paint, protects the probe.
The top heat shield is going to experience 1,300 degrees Celsius, and it
Thanks for watching. I'm still troubleshooting.
in the back, it's going to be room temperature. It's important to have this huge temperature difference. Those instruments in the back need to operate in about room temperature.
Since 2018, the probe's elongated orbit takes it progressively closer and closer to the sun. And in December 2021, the team announces a major breakthrough.
Parker Solar Probe had touched the sun. This is definitely a first. This is the monumental achievement of being able to say that we were inside the atmosphere of a star.
Some scientists assumed the sun's atmosphere was smooth like a ball. This is the boundary where the solar wind escapes the sun's gravity and magnetic pull and spills out into space. But Parker's data shows it is undulating, complex, and dynamic. As the probe barrels through the sun's atmosphere, it runs huge magnetic structures rising from the surface, called coronal pseudostreamers. These could be responsible for the rugged edge of the sun's atmosphere.
The particles of the solar wind are a plasma. We are just beginning to learn more and more about how they're thrown out of the sun. Knowing the shape of that surface is really important to understand the formation and acceleration of the solar wind towards us.
The strength of the solar wind depends on the behavior of the sun's magnetic field, which varies according to an 11-year cycle called the solar cycle. And according to that pattern, the expected activity in 2024 could make April eclipse particularly interesting for scientists.
In 2017, the sun was at a minimum. In 2024, the difference is going to be that the sun will be very active. It will be at a maximum. And those maximums are where you get the show. There could be a lot of activity going on. My dream is that there is actually a coronal mass ejection or a flare going off that we could see. That would be exciting.
Solar eclipses have captivated communities in North America for centuries. 3 hours northwest of what is now Albuquerque, this canyon was once home to the Chicoans, a Pueblo Native American people who farmed the land here until the 13th century. John Jihadi believes they were closely attuned to the sun's movements and rhythms.
What makes the Pueblo communities different from our neighbors throughout this entire region is that they were permanent agrarian societies. To be an agrarian society, that takes a great deal of planning and problem solving. If I plant too late, I may not get a bountiful harvest. If I plant too early, maybe I'll get a late frost. So by being able to have an understanding of what time it means as it applies to the seasons is essential for survival.
At the top of nearby Fajada Butte, the Chicoans track the sun to measure the seasons.
there were some slabs that projects sunlight on a spiral. On the equinox, the light hits a certain point in that, and that's why it's called the sun dagger.
The equinoxes mark the moments in the year when day and night are of roughly equal length. Knowing when these happen is vital for deciding when to plant and when to harvest. But the sun dagger is not the only evidence that Chicoans watch the skies closely. There's also a mysterious petroglyph here that suggests people on this continent may have witnessed eclipses that have passed across North America over centuries.
You see the circular symbol here. Perhaps that represents the sun in totality. Around the symbol, we see lines or curvatures, which perhaps we could interpret as maybe the corona of the sun or the flares of the sun that perhaps someone might see in a total eclipse.
Scientists today can calculate that in 1097, a total eclipse was visible here while the sun was nearing the peak of its solar cycle, solar maximum, when vast plumes would have extended from the corona.
That's the tantalizing thing about it. Much like whenever we have an eclipse in our time and age, people stop work. People want to go outside to record this monumental event because it's something unique and special. It connects us with the past. Those are the same celestial bodies that our predecessors saw. We're just really the same as they were. We just have different tools.
There are 574 recognized indigenous communities across the U.S. with varying perspectives on solar eclipses. The Navajo people consider an eclipse to be a moment of renewal that can be harmful if viewed. Cherokee tradition says a giant frog is swallowing the sun, and the frog must be scared away to bring back the daylight. For the casual observer, the timing and location of eclipses can appear random. After the April 2024 total solar eclipse, it will be 20 years until another is visible from the U.S. lower 48. However, the period of time between total eclipses can be much shorter.
Nature cooperating with Ballyhoo. Elaborate preparations were made.
In 1925, American astronomers watched a total eclipse as it passed from the middle of the country to the east coast. Some even flew in an airship to make observations. This fortunate generation had already seen 2 total solar eclipses in the previous 7 years, and would see another only 7 years later. Despite this apparent randomness, there is a complex pattern behind eclipses. And, astonishingly, it was discovered over 2,000 years ago. Ancient Babylon, situated in what is now modern Iraq. For centuries, astronomers here recorded every occasion an eclipse was reported. Eventually, around the 7th century BC, they spotted a pattern.
Some very clever Babylonian astronomers figured out that solar eclipses are governed by a cycle, and this is the so-called Saros cycle.
Today, we know that a total solar eclipse will take place somewhere on Earth about once every 18 months. But with centuries of data, the Babylonians realized there was a larger pattern. Every 18 years, the time between eclipses would repeat.
They could actually make an entire calendar of eclipse predictions simply by projecting these past eclipses into the future.
think I fixed the difficulties. I know I got interrupted, but I just wanted to get in, just say thank you guys for coming to the 88 Real Talk Podcast. I appreciate you guys. When you're on your way in, hit the like button, subscribe. Appreciate you. Thank you on your Sunday, and God bless you. Continue to enjoy the video. Thanks.
Astonishingly, the Babylonian predictions were accurate to within an average of 4 hours. But they couldn't tell where in the world the eclipse would take place.